For today's lesson, we're going to do a little review day. Today we're going to do a little review of the quadratic formula and also a little refresher on how to factor perfect cubes. Okay, these two skills, again, we've seen in the past, but we're going to just refresh our memories a little bit because we're going to need to be pretty good at them moving forward in the next couple lessons. Okay, so the first thing we're going to take a look at is the quadratic formula. Okay, if you remember the quadratic formula, okay, this is what it looks like. Okay, there's three letters A, B, and C. Okay, and it's going to be really important on this homework assignment and in future homework assignments that you show your work. Been kind of emphasizing that a little bit lately, so make sure you do that. Okay, so let's take a look and see if we can solve this one using the quadratic formula. One of the things that again is very helpful is to identify what our A, B, and C are before we plug them into the equation. Okay, if you remember, A is the number in front of the x squared, so A is -3. B is the number in front of x, and C is the number at the end, the constant. Okay, and once again, before we can use the quadratic formula, everything has to be moved over to one side and the equation has to be set equal to 0. It doesn't matter which side things are moved to, it just has to move one way or the other, and it is okay if the number in front is negative. Okay, so I have my A, B, and C. Let's plug it into the equation here. Okay, so it says x equals the opposite of b, so it's going to be -5 plus or minus the square root of b squared. Okay, and I'm going to square this, well, maybe I'll write it in here. It's going to be 5 squared minus 4 times -3 times 2, all over 2 times a, which is -3. Okay, so there it is with all the numbers in it. Okay, the next thing we want to do is we want to simplify the stuff under the radical. Okay, and if you were to use your calculator and simplify all this stuff under the radical here, it would turn into a 49. This is going to turn into a 49 all over -6. Okay, now that's the most important thing. That, well, I for sure need to see to here. Okay, like I said, show your work. Okay, now let's see, lastly here we want to see if we can simplify it. Okay, what we're going to look at is we're going to look at this number under the radical here, and we're going to ask ourselves if it can be simplified. Yeah, well, is 49 a perfect square? Does it have a nice square root? It sure does. And the square root of 49 turns into a 7. Okay, and now what I have for an equation here is I have this. I have x equals -5 plus or minus 7 all over -6. Okay, and when this number is a perfect square, we can actually take this one step further. We actually have two nice answers staring at us here. One of them is going to be -5 plus 7, which is 2 over -6, which can be simplified to -1/3. Okay, and the other one is -5 minus 7, which is -12 over -6, which turns into a +2. Okay, so again, when the number under the radical here is a perfect square, we should be able to get two nice answers out of this. Okay, we have to go this extra step. Don't leave your answer like this, but go that extra step and simplify them into your two nice answers. And again, always reduce your fractions. Okay, but again, I know I'm going to emphasize this a lot. Show your work. Okay, and especially simplifying this number under here. Okay, so we're going to do 3 of these, and each one's a little bit different. Okay, this one, and it all kind of centers around the number under the radical. When it's a perfect square, it's good news. Okay, here's a second one that I have. Okay, looks like this. Okay, everything's moved over to one side. Things are set up really good. I'm going to identify A, B, and C. Looks like A is 4, B is 4, and C is 8. So let's give our quadratic formula a shot with this. Okay, it's going to be the opposite of b, so -4 plus or minus the square root. Okay, now I started to do this on the last problem, but a lot of people like to square this number right away. So let's take a look at b and let's square it. Well, 4 squared is 16 minus 4 times 4 times 8. All over 2 times a, 2 times 4 is 8. So sometimes you can simplify things a little bit. Okay, and then now let's take one extra step here. And most of the time, this is going to be used or done with your calculator. Okay, But multiply and subtract all that stuff together, and let's see if we can get one number underneath the radical there. Okay? And if you did that underneath your radical, you're going to get negative 112. Negative 112. Okay, so we didn't do anything different compared to the last problem, but the number under the radical here is just a little bit different. And the significance about that is two things. Number one, is 112 a perfect square? No, it is not. It is not a perfect square. And the other important thing to make note of here is there's a negative. And what do we get when there's a negative sign underneath the radical? We get an I in our answer. Okay? Now, when I have i's, especially when I have i's, and a number that is not a perfect square, we need to simplify it. Okay? And if you looked up 112 on your factor sheet and went down the columns and looked for the black ones, you would find 16 and 7. 16 and 7 multiply together to give you 112. And the square root of 16 is 4. Okay, so this changes into negative 4 plus or minus. The 4 comes out here. And remember, when there's a negative, I also get an I in my answer with the square root of 7 left over, all divided by 8. Okay. Now again, we're almost done. The last thing we have to check for on these, and some people forgot to do this on the test, is can something be divided into all three of those big numbers out in front? Has to go into all three. And if you look closely, 4 can go into all three of those. So if I divide them all by 4, I get a 1, and a 2. So what I have left here is I have a negative 1 plus or minus 1i square roots of 7 all over 2. And just like the last problem, the quadratic formula gives us 2 answers. Okay? And because this isn't a perfect square and it has an I in it, we're done. We're going to leave it just like that. We don't have to take it any further. But ones with i's, okay, ones with negative numbers under the radical, rather, are going to have i's in your answer. Okay, so that was the second problem again. Again, that number under the radical was a little bit different. And here's my third and final one, quadratic formula problem. Looks like this. Again, things are arranged correctly. Let's try this one. Okay, I'm going to get 6. B is a negative 2. And C is negative 21. Okay, so there's my A, B, and C. If I try my quadratic formula, the opposite of E, in this case it's going to be the opposite of negative 2 is positive 2, plus or minus the square root of B squared. And this is, again, is where a few people went wrong. Negative 2 squared is positive 4. That number will always be a positive number. So there's B squared minus 4 times A times negative 21. Oops, negative 21, sorry. All over 2A. And 2 times 6 is 12. So again, now it's calculator time. Okay, we're going to grab our calculator, and we're going to try and simplify all that stuff underneath the radical there. Okay? If you take a second and simplify all that stuff under the radical, you're going to get kind of a big number. It should turn into 508. 508. Okay, now holy cow. Okay, is 508 what we're going to hope for? We hope for that number is a perfect square. But if you were to try that on your calculator by doing the square root of a 508, it's not going to work. It's not a nice number. Okay, that means hopefully we can find something that's a perfect square that goes into it. Now, obviously 508 isn't on your factor sheet. But if you remember a long time ago when we did these, we want to see if a perfect square goes into those. Okay, and if you make a little list of your perfect squares, well, 2 squared is 4, 3 squared is 9, 5 squared is 25. Those are really the 3 numbers that you have to try. Okay, and if you tried taking out a 4, 4 goes into that 127 times. Okay, but 4 is kind of the key word, or the key number there, rather. And the square root of 4 we know is 2. Okay? Okay, and then if you look at 127, that is on your factor sheet. But if you were to look at that, that's a prime number, and it doesn't go any further. Okay? So what I have for kind of a tentative answer here, okay, is I have x equals 2 plus or minus 2 square roots of 127 all over 12. Okay, and last but not least, again, let's look at the big numbers. Is there something that can be divided into all three of those? Yes, I can take out a 2. Again, that turns to a 1, and a 6. So kind of my grand finale simplified answer here turns into 1 plus or minus the square root of 127 all over 6. Okay? And if we were to leave our answer like that, okay, in simplified radical form, we'd be done. Okay? On this worksheet, though, I'm going to have you go one step further. I want you to find the decimal equivalents. Okay? And we know there's 2 answers there. They're just not going to be very pretty. Okay? And this is going to be pretty easy. We just type it in the calculator. Okay, you're going to pick up your calculator. You're going to type 1 plus the square root of 127. But after you hit the square root of 127, right here, make sure you press enter so that it does that addition and then divide it by 6. Okay? And if you did that, okay, you're going to get a decimal. And let's round it either 1 decimal place or 2 decimal places. Okay? I'm going to round it, and if you looked on your calculator, it would round to 2.04. Okay? And to find the other one then, we're going to do 1 minus the square root of 127 on our calculator. Press enter, divided by 6, and again, you're going to get a negative number this time. It's going to be negative, and if I go 2 decimal places, it's negative 1.71. Okay? And these are the answers I'm looking for there. Okay? Most oftentimes when we encounter word problems, especially word problems, we're going to get some ugly numbers, some ugly decimals, okay, ugly radicals, but we're going to want our answer in decimal form. Okay? And that's what we're going to shoot for down the road. Okay? But once again, just so we're all crystal clear, I need to see this work along the way. Okay? I need to see that number right there especially. Okay? The 127 and simplified. But make sure you show your work. Okay, so there's a little quick refresher on the quadratic formula. There were 3 types of problems. Okay, the first one we saw was when the number under here was a perfect square, and it led us to a couple nice answers. Granted, it's a fraction, but that's okay. Okay, the second one that we did, the number under the radical was a negative number, which led to us having an I in our answer. And the third one that we did was just a big, ugly number that was not a perfect square, no i's, it wasn't negative, but it led us to having 2 decimal answers. Okay? All right. Yes. Okay? The last thing we're going to concentrate on and focus on here is factoring perfect cubes, which was the other thing. Okay, that was in this little review session today. Over here, if you remember from a few days back, okay, this is how we factor perfect cubes. Okay? To get the stuff in the first parenthesis, we took the cube root of each one, and then we use this to get the second one. Okay? So when I look at this one, I want to ask myself, how about 125 and 64? Are they perfect cubes? Do they have nice cube roots? And again, a few days back, we wrote a list of the perfect cubes right here, and we know that 125 is a perfect cube because the cube root of 125 is 5. Okay? And 64 is also a perfect cube. The cube root of 64 is 4. Okay? So if I was to write this in my parentheses here, my first parenthesis, and I'm going to use the bottom one because it's subtraction. Okay? We're going to get a 5, and then the cube root of y cubed is y. And we're going to get a 4w there. It's 5y minus 4w. I'm just taking the cube root of each one of those terms. Okay? And then, if you remember, how do we get the second part here? Okay, this first term comes from the first number squared. So I squared this one. 5y squared is 25y squared. We change the sign, and then we multiply the 2 together. That's 20yw. Okay? And then for the very last term, I squared the last term. That's going to be 16w squared. Okay? And we're done. And if you remember from the other day, this stuff is not factorable any further. That's a dead end. That's as far as you can go in terms of factoring. Okay? Hang on a second. Okay. All right, so you're going to see some that are going to have you factor. That's all you have to do is factor. Break it apart into its different pieces. And the last one here, there are going to be a couple problems on the perfect cube side of the worksheet here that are going to want you to factor and then solve. So we're going to get it broken apart into its two pieces, and then we're going to solve it as well. Okay? Well, let's look at this. I'm trying to find perfect cubes, but bad news. I'm looking at 24. That's not a perfect cube. And neither is 81. 81 is a perfect square, but not a perfect cube. So how are we going to do this? Okay, well, if you remember from the other day again, if they're not perfect squares or not perfect cubes right out of the gates, the one thing we always look for is a greatest common factor. Is there something that goes into 24 and 81? And again, if you look at your factor sheet and went down the list on both of them, you would see that 3 goes into both of them. I can take out a 3 and I can also take out a y. They each have a y in common. Watch what happens when I divide out a 3. 24 divided by 3 gives me 8 with a y cubed. And 81 divided by 3 is 27. Now, hey, good news. I look at those two numbers that are left over in the parentheses, and they are perfect cubes again. Okay, so I can use my little perfect cube pattern down here. This is going to break apart into a little piece and a big piece. Okay, and the way that I find the numbers in the front piece is I do the cube root. The cube root of 8 is 2 with a y, and the cube root of 27 is 3. Okay, so there's my first parenthesis, the small one. I'm going to use that to make the second one. And what I do is, again, is I square the first number to get 4y squared, change the sign to plus, and then I multiply the two together to get 6y, and I square the last number to get 9. Okay, so that's what I'm looking at right there. Okay, if I was to factor those. Okay, and then this 3y just comes along for the ride. Okay, so if the directions just wanted you to factor, we'd be done. I'd have 1, 2, 3 parts to my answer. Okay, but up here it wants us to go one step further. It wants us to solve it. It wants us to find the solutions, or in other words, the zeros. Okay, and 2 out of the 3 are pretty easy here. Okay, the first one, if you remember this from factoring from a while ago, if there's a y or an x or a variable factored out in front, 0 is a solution. There's one of them. Okay? Again, if you remember from factoring in the past, this is just a regular old binomial. Again, I can set the equation equal to 0. So maybe I should do that. There's a shortcut, but maybe I'll set it equal to 0. So 2y minus 3 has to be equal to 0. I'm going to add 3 and then divide by 2. So y equals 3/2. Maybe there's some of you that could see the opposite of this number, which was positive 3 divided by 2. Yep, you don't necessarily have to show any work for that one if you remember that little shortcut. Okay, so those two weren't so bad. Okay, but now the last one here, if you remember me telling you this before, this was not factorable. Okay, so now what do we do? Well, how do I solve a quadratic equation that cannot be factored? We get to use our good buddy, the quadratic formula. Okay, so this last one here, in a perfect cube one, to find the solution of the big part, we have to use the quadratic formula. Oops. Write that here. We always have to use, still can't write, sorry. Use the quadratic formula on this part. Okay, and we just got done reviewing that again. So let's give it a shot. Okay, so again, I'm going to let A is 4, B is 6, and C is 9. Okay, I'm going to scooch this up just a tiny bit. Okay, so let's give it a shot. So I'm going to move this over a little bit. A is 4, B is 6, and C is 9. All right, so we're going to do, oops, this is Y this time. It's the opposite of B, which is going to be negative 6 plus or minus the square root, oops, of B squared. Well, 6 squared is 36, minus 4 times A times C, all over 2A, and 2 times 4 is 8. Okay? So here we go. I'm going to scoot this up a little bit. I'm going to simplify the stuff under the radical. I want to get a nice looking number under there. Okay, and if I grab my calculator, okay, I'm going to get 36 minus 4 times 4 times 9. I end up with negative 108. Negative 108. When I look at that, the first thing that pops into my mind or jumps out at me is that there's a negative. So that means we're going to have an I in our answer. Okay? And then I look at the 108. Is 108 a perfect square? It is not. It is not a perfect square. But when I go to my factor sheet and I look for the factors of 108 and I look for a black one, I see two of them there. There's 36 and 3. Okay? 36 and 3. 36 times 3 is 108. We know the square root of 36 is 6. If I put this all back together, again, I get negative 6 plus or minus. It's going to be a 6i with the square root of 3 all over 8. And then last but not least, I'm seeing this quite often today here, where I can divide something into all three of those numbers, and I think I can take a 2 into all of those. And if I divide them all by 2, I get a 3, and a 4. So ultimately, for this part of my answer, I get 3 plus or minus 3i square roots of 3 all over 4. A lot of 3's in that answer. Okay? But this has two answers, 3 plus all that stuff divided by 4 and 3 minus all that stuff divided by 4. So there's two answers. And then we also had two more right here, this one and this one, for a total of 4 solutions. And I've kind of hinted at this over the last couple days. But the degree of that polynomial starts out as a 4th power. We had 4 answers. We're going to explore that in a future lesson here. Okay? But today it's a review of the quadratic formula and perfect cubes. Okay, you're going to get a worksheet as an assignment. Okay? On the side that says perfect cubes, and I put this in the directions on the assignment, there are 3 problems that are circled, number 1, 14, and 16. On numbers 1, 14, and 16, I want you to solve it just like this one. They're perfect cubes. You got to factor it and find your solutions on those 3 problems only. All the others, you can just leave it in factored form. You could stop right here. Okay? On the back side, on the quadratic formula problem, there are 3 problems that are starred, numbers 1, 2, and 8. Those ones that have stars by it are ones that are going to have I's in the answer. Okay, that's the significance of the stars on the back side. The starred ones, numbers 1, 2, and 8, have an I, meaning you're going to get a negative number under the radical on the quadratic formula. Okay? All right, thanks for tuning in.